All right, welcome back, everybody. Let's continue our exploration of the language. So we've looked at arithmetics, comparison, and these are all the sort of things you can put in the predicates, right? When you have these predicates to filter, and we'll see other places where you can also put them, like the where clause and so on. So in short, there's the EQ, LE, and so on for single items, and otherwise there is these actual symbols, equal, and so on, that have the superpowers of existential quantification on sequences. All right. And again, don't worry too much, because if you have single items and you use the symbols, it's going to work too, and the many engines will figure it out. So you don't even have to worry too much about the distinction. Okay, then you have logic, but again, you're computer scientists, so there is ends, there is or, there is not, and there's parentheses. So now you can play around as much as you want with first order logic. Yeah, two values, not like SQL. In SQL, there's false, true, and unknown, but here it's just false or true. What happens is that if something is not a Boolean, it's automatically going to be transformed to a Boolean. This is called the effective Boolean value. So for example, if you do if with an empty string, that's going to be considered false. So if false, so the else is going to be taken. If you have if foo with a non-empty string, then that's true. So it's going to go to the then part. If zero, that's actually just like C or C++, if you're used to C or C++. If zero is going to be considered false, and that's going to go to the else part. If non-zero is that's going to go to the then part. This is true. All right. If of the empty sequence, that's false. So that goes to the then clause. If of a sequence that starts with an array or an object, that goes to true, so to the then clause. This is in fact very practical, because again, that gives you a shortcut. You can use if for testing the existence. So if you have a collection of objects or a collection of arrays, and you just do if the collection of objects, that's automatically testing for whether it's empty or not, right? Otherwise, you would have to do it explicitly, like you have to add an exists or empty function call, which you could, but you don't have to, because of the way that it automatically maps the empty sequence to false and a sequence starting with an object or array to true. All right? So good, so far so good. Arithmetics, logic, comparison. You have all you need in order to do very fancy predicates to filter on. All right? The next thing is that, as I said, this is a functional language, so it's like a Lego game, so you can compose all you want. This is actually quite fun to do. So any expression can be the operand of any other expression. So of course, there's still precedence. So if you're not happy with the precedence, you can just add parentheses, just like in any other languages. Like if you have addition and multiplication, you can override the order and prioritize addition with parentheses. So here's an example of some query that I just made up just to show composability. 2 plus 2, that's executed to 4. Then we have an object, put in an array, put in an object. Dot B is extracting the array. Then you open the array, which has one object. So bam, it's there. Dot A is taking 4. 1 plus 4 is 5. 5 to 50 gives you that. There you go. So you see, composable, I had some complicated expression there. I just nested expressions in expressions, and that's evaluated all the way to this. For whom is that clear? Right. So all I need to do is really give you the Lego components. There's actually less than 40. It's typically, I think last time I counted was 37 pieces. You already know a lot of them, actually: arithmetics, logic, comparison, object lookup, array unboxing, and so on. So you just need to basically make yourself familiar with all the pieces, right? So in terms of precedence, you don't really have to know it by heart, right? But just be aware there is a precedence, right? So the comma has the lowest precedence, and the literals, the constructors have the highest precedence. Whenever you're not happy with that, just use parentheses. If you have a doubt, just put parentheses. It never costs anything to put parentheses in there if you're not sure, right? So you can use and abuse parentheses all you want. Okay, so you see, what's really nice about the language is that you can take JSON, but you can dynamically use that JSON, dynamically generate that JSON. So here, for example, you have something that looks like a JSON object, but inside you can see that there's actually JSON queries rather than JSON literals. So for example, at string length of foobar is actually going to generate at 6, right? Here, you see, because 6 comes from the string length. And here you have an array with, we'll see the for loops slightly later, the for clause, but this basically iterates 1 to 10 and then returns the long, it casts to a long integer, and that creates an array with everything from 1 to 10. So you see, this is the results. This is a sequence of one object that is the result, so everything's computed. This is the query. So that should give you the intuition of how you can literally take JSON and replace literals with codes that will evaluate and be put exactly where they are in the structure. For whom is that clear? All right. For whom does that feel like a Lego game? Okay. Okay. Now let me give you some more of these 40 components. So there's data flow. And again, your computer scientist, that's going to be easy for you. There is if then else. So as you can imagine, it's looking at whether it's true or false, given what I told you about empty strings and so on. If it's true, then it returns what is in the then. If it's false, it returns what is in the else. Note that this is a functional if then else. It's not an imperative if then else. So actually this if then else, if you want to compare it to something in Java or C++, that would be what is known as the ternary expression. Who knows the ternary expression? It's when you have this question mark and this colon. That's basically what it is. It's like count blah, 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 question mark, large file, colon, small file. That's what it would be equivalent to. But of course, since it's a functional language, we actually get the luxury to use the if then else syntax to do the same thing. And that's much easier to read for whoever is reading the query. Okay, then we have the switch case. And again, that shouldn't surprise you very much because this is the sort of things you see also in Java, Python, and so on. Just remember that it's a functional switch. So it's not nothing imperative in there. It's just looking at the value that you pass in the switch and then comparing it to every single one of the cases and just picking the right branch and returning whatever the result is of the query on the right of the branch. Okay. And then we have also try catch, which is a nice way of catching errors. So for example, if you're afraid of dividing by 0, or if you're afraid of casting a string to an integer and the string is not actually an integer literal, you can still catch it with this, and then you can still return something without actually forwarding the error. Again, but you're computer scientist, so again, I don't think I need to say much more about that, just that is functional. Let's get back to our data sets. So you see the fancy things I can do now. So .payload.commits. Then I take the array. This is an example, coming back to the question you asked earlier. Think of what's going on here. This is a sequence of, let's say, billions. Let's pretend it's billions. So billions of objects there. .payload is going to return billions of objects. .commits, the billions of objects in the billions of arrays, commits is going to be an array. So here we have billions of arrays, and then we have these square brackets that's going to unbox each one of these billion arrays. So this is extracting the content of these billion arrays and flattening again. So this is a flat map as you asked earlier, right? So we open one level of arrays and flatten it back. And then this gives us a sequence of all the objects that were nested in these arrays, .author.email, and this is what you get. This is a flat list of all these emails. There is a name commonly given to that sort of queries. This is also called the path expression, right? Because you are really looking at a path within the collection of objects, right? And the result of that path is, the path expression is always a flat list of items, a sequence of items. For whom is that natural? Right? So who feels capable of writing expressions like that, path expressions in that way? Okay. So you can explore collections now, even if you don't know them, you can just figure it out. What are we doing here? Well, there is a function that returns the size of an array, so the number of items in the array. So we can actually look at this payload.commits, which is always an array. Let's pick the ones that have at least 5 items. Some of them have less, some of them have more. So let's only keep those objects in the collection that have at least 5 commits. So the GitHub events with at least 5 commits. How many are there? 5,643, right? This is the sort of things that you can do. You could also look at the specific position in an array. Here you need to double the angle brackets. There's a simple reason, it's to not confuse it with the predicates. That's all. So this is why if you want to access a position in an array, the first item in the array, double square bracket 1. Don't confuse that with the single square bracket. The single square bracket picks the first element in a sequence, right? So if you have a sequence of one array and you do a single square bracket 1, it's just returning that array. It's not actually taking what's inside. But if you have a double square bracket, it's actually going to take the first item in the array. Now, if you have a billion arrays, then it's going to extract the first item of each one of these billion arrays, right? So it's going to be returning all the first commits of every event, and it's going to return the email of the author, right? Yes? Maybe the catch box. Yeah.
So if we want only the first element of one of those multiple arrays, then we nest it once again.
So for example, you would have commits and then another array. Then you could use a comma expression. So there are, I will show you the for loop because then you could use that, and then you can use a comma, and then you can have a path expression to your first array, then one, comma, a path expression to the second array, and then one, right? So the comma expression allows you to write complete code, right? It's Turing complete. You can write a Turing machine with that. So basically anything you can do it. Right? Okay. Did that answer your question? Awesome. Okay. Now let's do exactly the same thing, because that's very nested. Actually, you see it's a functional language when you do that, because that's really a chain of expressions. And there's actual function calls in there, because these are not counts, distinct values, JSON files do not have expressions. Okay. We can rewrite this exactly the same thing with a chain of let clauses. Let the path be git archive big JSON. Let events be JSON file of the path. Let actors be events.actor. Let logins be actors.login. Let distinct logins be distinct values of logins, and return the count of distinct logins. This is not, what did I do? Probably didn't take the same queries. Well, let's use your imagination. I'm pretty sure you can rewrite, given the lets, you can rewrite it, in this way, given the lets here. Let's do it as an exercise. I'm pretty sure you can do it. Who could rewrite this as a single big chain of function calls? Okay, very good. So you can have a cascade of let clauses. In fact, if you already know how to program in a functional language like Haskell or F# or any other language, a chain of let clauses should not surprise you, right? Who already saw chains of let clauses in a functional language? Many of you, right? So what's important is that these are not variable assignments. These are just variable bindings. You're declaratively saying that this variable is this and this variable is that, and then return, and then anything after that, it's lost. The binding is only available in subsequent clauses and in the return clause, and then it's gone. Okay, so that's a cascade of let clauses. Now, in addition to let, you also have for. And for is an iteration. So here for every event, for $event in JSON file, so $event is going to be bound to each one of the billion items of the collection, that one at a time. So $event is always a single object. It's just iteratively going through them. Then for every such event, the number of commits is the size of the commits array, right? So .events is an object, .payload is one object, .commits is one object, one array, and then size returns one integer. So NB commits every time will be one integer, but it's going to be done for every event, right? And so every event, you return this object right there that has the ID of the event plus the number of commits that you computed there. This returns one object like that for every event in the collection. For every event, you're generating this object with the ID and the number of commits. This is what you get, right? So this is kind of a map, if you want. This is doing a map. We are mapping every object of the collection to a new object. Yes, we have a question here. There you go. Well, you're good at that.
Just a quick question. Does the for loop scope end at the return? That's what
they go, sorry?
The scope for the for loop.
Oh,
does it end always in a return, and the return is what marks its end? So
yep.
Then if you would have a sequence of such for loops, then each of them would have a level of return, right? There's no indentation or things like that.
So let me give an approximate answer, and then let me give a more precise answer, knowing that many slides are following on the for. Your intuition is correct that the scope of that $event ends with the return. That you're correct about. The one thing to pay attention to, and I also might have been guilty of that in introducing them because I wanted to not scare you right away, given that you're used to for loops in C++ and Java. Technically, this is not called a for loop in a functional language. This is called a for clause. In fact, this would be like the from clause of SQL. That would be the right way to understand this for. This is like the from clause of SQL. And the select would be the return. So whenever you have for return, that's like select from, just the other way around. So it's as if you would have select ID number of commits from git archive big.json. That's the way to see it, right? So you see that it's not a for loop in the sense that you don't have an assignment, you don't have a change of value of the variable, you just have one binding for every object of the collection, and you're mapping it to the results, right? Did it help? I have plenty of slides that are coming to explain that in details, the for, the lets, and so on. Here they are. So there is a name, as it turns out, for these beautiful expressions, for, let, return, that are actually the equivalent of select from where group by having in JSONic. They are called the flower expressions. Beautiful name. It's because of for, let, where, order by, return, as in the original version of the language. So this is a pun, and it's intentional that the W comes before the O and that there is no E, right? So this is just how they are called, flower expressions. So let me then open a parenthesis and now tell you about flower expressions for the next couple of minutes. We've already seen for and let, right? So let's see what happens. Here we have one let. It says that x is equal to 2. So we are binding x to 2 and then returning x times x. So that's 4, right? If I have a for, that's going to go through each one of them. So here we have a sequence of 10 integers, 1 to 10. And for every one of these integers, we in turn bind this $x. So first $x is 1, then $x is 2, then $x is 3, and so on. And for every one of these, we return the number and the square. So this returns, you see, 1 to 10, and then the square, 1 to 100. For whom is that clear? Okay. So normally for simple expressions like that, usually it's quite intuitive, right? Maybe because you could also imagine that this is close to the imperative way of looking at a for loop, right? Things become more complicated when you have more complicated flower expressions. Yet there is one way to actually look at it. In order to see that, let's introduce one more clause. For let's look at where now. So imagine what this is doing. For x in 1 to 10, so we bind in turn to all integers from 1 to 10, where, that's a selection, we filter out some of these bindings, where x minus 2 is greater than 5. So this means that we basically have 8, 9, and 10 that are surviving, right? So this where clause is basically kicking out some of the values, some of the bindings of $x that do not satisfy this predicate. That would be in an imperative language, that would be as if you had an if blah, 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 and then continue, right, to exit. Of course, it's not a good idea that I start mapping this to imperative languages, because that would be as if I were teaching French to you, but translating everything to German, right? So I shouldn't be doing that. But maybe this helps you a bit to understand how this would be, this could be implemented imperatively. All right, but as you can imagine, it's not actually implemented iteratively with a for loop and an if continue. As you will see, this is actually implemented with data frames. So this actually will be done in parallel when there are billions of items, but more later. So for every x between 1 and 10, we return the square, but only for those satisfying the conditions. So the survivors are 8, 9, and 10 for x, and thus the result is 64, 81, 100. For whom is that clear? All right. Yeah.
Semantically, the return doesn't return each of these, it returns a sequence of.
Yes, this is a flat map again. So the return expression might return multiple items, right? So in the cases we've seen so far, it's one item at a time. But you could absolutely have a return clause that returns 2 items, and the next time 3, and the next time 4, and so on. Then everything is flattened again, right? So imagine that I had, let me give you an example. It's going to be, I require a bit of space in your brain to do that. Imagine that I give you the query for $x in 1 to 3, return 1 to $x. What does this return? There are no arrays in there, right? It's just for x. So exactly, this is flattened. That's the trick. You could think, okay, that's nested, so it's a sequence of sequences, but actually not, it's flattened. So what you get for $x in 1 to 3, return 1 to x, you get 1, 1, 2, 1, 2, 3, flat. right? It's like a flat map in Spark. Okay, does it answer your question? Yes.
It's kind of like $X is a sequence, right?
In that case, it's an item. $X is an item, one at a time. $X is never a sequence here. It's always an item. Basically, you have to think of this $X times $X. This here is going to be evaluated 10 times. It's evaluated the first time with $X being 1, that gives you 1. It's going to be evaluated the second time with $X being 2, that gives you 4, and so on. Except that because of the where clause, you don't actually return those 1 and 2. So then it returns 8 times 8, 9 times 9, 10 times 10. Think of it as, let's call it the static type of $X, or the dynamic type, if you want, doesn't matter. The type of $X is that it's one item. One item. $X is one item. In that case, you could even say $X is an integer, right? I'll tell you more about types. But since there is the for clause, what the for clause is doing is that it's taking what was a sequence. This was a sequence. But because of the for clause, you're now having one item at a time with the variable. Let would be different. If you had a let, then if you had let $X equals 1 to 10, then X is the sequence 1, 2, 3, 4, 5, all the way to 10, right? It's a very big difference between for and let. Does it help? Okay, now we have order by. Order by is reorganizing the order of the bindings. So here you were binding $X to every event, every country in the world, maybe 200 of them. But now I'm reorganizing these bindings by descending population, right? So I'm going to go like China, India, US, and so on and so on, right? All right, so, and then you return the name. So, I think maybe I anticipated a bit. I don't know if I actually did this. I think there is soon going to be a swap between the two. All right, so this gives you the sequence of countries in decreasing order. All right?
Yep, there's a,
yeah,
there's a question.
Going back to your example with the return 1 to X, to $X, what if instead of sequence, we would do like return an array?
Then you return a sequence of arrays. Then you would return a sequence of 3 arrays, the first array with 1, the second array with 1, 2, and the third array with 1, 2, 3.
So it's just the sequences that have special bindings that they are flat and
yeah, exactly. And the arrays are the trick to prevent the flattening. If you add the square brackets, you're boxing the sequences in arrays and you allow them to nest. If you don't use arrays, it's flattening always. You never nest sequences, right? That's a very good point. All right, who understands this, the order by? Right, so you reorganize the bindings. This you couldn't do in C++ or Java, right? I don't know that in C++ or Java, you can actually have a for loop and then reorganize the order of evaluation. But here you can, because it's a declarative language. All right, then you have group by, that's magic. I told you it's like the selects from where, so probably you expected the group by to appear as well. So look at what this is doing. It's fancier than SQL. It's the same as SQL, but fancier. So here's what's going to happen. This is like the from, so it's select blah, blah, blah from countries group by continent. This would be the SQL equivalent. So now the way you understand the flower expressions is you need to go top down. You typically have aligned clauses. They're always aligned vertically, the clauses in the same flower. So you have a for, then a group by, then a return. And then you have a nested flower in there with a for, and then a return. All right, so you have, what happens there is that you are grouping these objects there that are in the countries by continent. So you're creating one group for every continent, right? And then $X after the group by is no longer a single item. After the group by, $X is a sequence of all of those in the same group. So you're going to have first a binding with $continent Europe, and then $X is going to be like Switzerland, France, Germany, and so on and so on. Then you have a second binding with continent Asia, and then you have $X that is India, China, Pakistan, and so on. Then you have North America, US, Canada, and so on and so on. So you grouped, and you have fewer bindings because now they are grouped by continents. But what's particular here, and that you didn't have in SQL, is that $X, which used to be a single item, is now a sequence within each group, right? And then for every such group, you return the grouping key, continents, and then the countries. And again, $X is the sequence of countries for that continent, and you iterate. So here I was fancy, you actually didn't need that. You could have just written $X.name, right? But I just wanted to show you a nested flower. That's the reason I did that. So you iterate, you can iterate again on the countries within that continent, returning the name. For whom is that clear? This is what it returns, right? Who understand that this query returns that? Okay, very good. All right, so now, you probably used your intuition until now. In fact, flower expressions can use clauses in pretty much any order you'd like, but there are a few constraints. Rule number 1, a flower expression always starts with either a for or a let. There is no exception to that. Always a for or a let, either of the two. You will never see any expression starting with a group by. Who would start an expression with a group by, right? So group by, order by, where, never. Always starts with for or let. That's rule number 1. Rule number 2 is it always ends with return, right? So everything in between can be anything you want. You can have for, let, where, group by, order by, where, order by, for, let, order by, group by, let, for, let, where, order by, return. That's an absolutely valid flower expression. So you see the power of that. It's more powerful than SQL. In SQL, you cannot do that at all. It has to be select from where, group by having, order by, limit of set. That's it. But here, it's more general. And in fact, this was designed by the same people and standardized by the same people, some of the same people involved in SQL as well. So this is a very, very smart design. So now that might answer your question of why it's not the same order, like you have select from where, so why don't we have return for where, right, you might think. But this is actually because it's much simpler for the brain to actually understand what's going on in this generalized way of doing things, because if you put the return at the end, it's really a flow top to bottom. All you need to do is follow the flow of the bindings top to bottom. In SQL, you have to kind of think with the from and the where and then go to the select and so on. It's a bit more circumvoluted, but here it's really literally top to bottom. So what happens is that you can think of the for clause as generating a stream of bindings in turn all the way from 1 to 10. So that's 10 bindings. You can represent them in a table actually. And then the where clause for each one of these bindings is evaluated to true or false. And then you only keep the bindings that have true. So this is how it goes for the where clause. And then the return clause is again mapping each binding to an evaluation of this expression right there in the context of the binding. So you evaluate this for 8, then you evaluate it for 9, and then you evaluate it for 10. For whom does that make sense? So this is a tuple stream. It's a stream of tuples, and this actually is true for everything. So this is why this expression returns that. Now, let's take a for, a let, and a return and see what happens. For gives us 5 bindings. So it's a stream of 5 tuples, 5 bindings. Let is adding a binding to y in addition to the binding of x. So now, for every tuple, we have both a value of x and a value of y. So this is why you can visualize that. It's a visualization. You can visualize that as a 2-column table. You have a first binding where x is 1 and $y is x minus 2, so minus 1. Then x is 2 in the second binding and y is 0. Then x is 3 and y is 1 and so on and so on. For whom does that make sense? So the let clause can be seen as adding one binding to all the former bindings you had in the previous 100 clauses, and you can view it as one new column to the table representation of the tuple stream. And then return x times y. So you see 1 times minus 1, 2 times 0, 3 times 1, 4 times 2, 5 times 3. If you have this visualization as tuple streams, then you'll understand any flower expression, and you can see how it generalizes actually very nicely, right? Group by is a bit the same. You see that you have this binding from 1 to 5. Group by follows. And what does the group by do? Now I'm trying to just adjust because there is a bit of this light noise there. All right. So see what happens. First, it's just as if it were a let. We are creating the Y group by variable. So we are creating that column with the grouping key, which is here the modulo 2. So we put the even numbers in a group and the odd numbers in another group. So 1, 3, and 5 will go to the bucket 1, and 2 and 4 will go to the bucket 0. But I haven't created my buckets just yet. For the moment, I just generated my grouping key, right? So 1 is odd, 2 is even, 3 is odd, 4 is even, and 5 is odd. Next, that's the group by. I now group by Y. So how many distinct values of Y are there? 2. There's 1 and 0. So now I have 2 tuples with 1 and 0. And again, as I told you, we group together all the values of X, 1, 3, 5. They are now put in a sequence. So this is really X bounds to the sequence 1, 3, 5. And 2 and 4, which both were associated with 0, they are now in the sequence 2, 4. So you see that group by changes the $X by putting it into sequences that belong to the same group. And then return is like this. So foo 1 and bar is 3 because we picked the count. So the count here is 3. And then here 0 and the count is 2. For whom is that clear? Right. So these visuals with these stable representations of the tuple streams are actually super useful. In fact, in practice, these flower expressions, they are implemented as data frames. These here are actual data frames that are going to run on Spark, distributed over the cluster. That's the magic. But as the user, you never see that. As the user, you just write that, and it just returns the results. Okay, so you see that you can do fancy things with this data set again. You can sort by the number of commits. So you have a let clause, so you see any order. So a 4 followed by a let with the number of commits. Then we order by the number of commits, and then we project. That's how we specify on these specific fields. We project to just ID and type. And we get now these commits, ordered by descending number of commits. Sorry, we get the events sorted by decreasing number of commits, and we get every time the ID and the type, right? The group by is the same. We can do a group by on our data set. So now we can group the events in GitHub by the size of the commits. So now we create a bucket for every number of commits. These are all the events with 1 commit. These are all the events with 2 commits. These are all the events with 3 commits, and so on. And now I use a little trick. That's the sort of things you cannot do in SQL or Spark SQL. Because what's going to happen is that maybe there is no commits in some of it because of the heterogeneity of the collection. So maybe some of the objects will not have any commit array. So what's going to happen is that this is going to be returning the empty sequence. But I don't like that. I don't like the empty sequence because I'd like a number of commits. So if I have the empty sequence, I'd like 0, please, right? So let's make it 0. And here the trick is as follows. If it turns out to be the empty sequence, and I append here a 0 and then pick the first of the 2, think of the 2 cases. If it's not the empty sequence, it's going to pick the size. If the size is an empty sequence, it's going to pick 0. That's just a trick to do that. So now we're grouping by commits, 0 commits, 1 commit, and so on. And you can see that's called a histogram. That's a histogram of the events based on the number of commits. You can actually use your favorite Python library to create a fancy pie chart and histogram with these things, right? This is outside of scope of my course because I'm not very talented at doing these things. But as you can imagine, this is the sort of things you then export to a CSV file and then use a visualization tool to create your graphs. All right. I'm going to take another break from the data set here, going to the relational algebra. I said that the flower expression is like the select from where. Maybe I can come back to this idea that it's like the select from where by going one by one through the relational algebra things we can do. Imagine that I have 2 data sets, one with products.json, the other one with starts.json, and I have this foreign key that the store here is pointing to the ID here. So for example, I have a teapot with the ID 7 that is sold in 2 in Germany. Okay, so this is basically a join, right? And actually that works too, JSONing. So for example, if I take now for every product where the store is 1, I just filter on the store being 1 and I get this, right? This is nothing new here. Then I can instead, so this was selection, right? I can project to just the ID and the type. So imagine I take the product here, but I only want the ID and the type I want to forget about the store. Then I can just use the project function. Then I can order by ID. So here, actually, it was already ordered, so it's a bit silly, I admit, but technically you can pretend that it wasn't ordered, then now it's ordered by ID, right? So with order by, you can group to do your histograms with aggregating by type and counting the number of products of every type. So here you see you have 4 TVs, 1 phone, and 2 teapots. Right? If you look, I think I probably did it right? 4 TVs, 1, 2, 3, 4, 2 teapots and 1 phone. Yeah. So you can group, right? And this now becomes magical. You can join. How do you join? It's a double for. You use a double for that would do the Cartesian product, right? But then you have this where, and here you filter with the foreign key store pointing to the primary key of the other collection ID. And then you display for every matched product and store the type and the country. So here you have a TV sold in Switzerland, a TV sold in Germany, a phone sold in Germany, and so on and so on. Who sees that this is a join here? This is the same as you would have in SQL with select from table 1, table 2, where, and then the joining criterion. Right? That would be a bit similar. Here you just use 2 for, and this is going to be executed efficiently. RumbleDB is able to push that down to a join in Spark SQL automatically. Then you can have left outer joins, which is in order to, for every product you want to return, to find the store if it exists. So this allowing empty is just going, if that's the empty sequence, then $S will be the empty sequence. If you don't have allowing empty, it's just going to skip the binding. That's the difference. If this is the empty sequence, then the flower expression will return nothing for that binding. But if you do allowing empty, then $S will in fact be bound to the empty sequence if it was empty. So you return for every product the type of product and the country. This is actually a very similar query, right? The only difference is that instead of a where clause here, I decided to use a predicate in the second collection, but this is really equivalent here and here, right? The only thing that wouldn't be equivalent is the allowing empty that allows my type foo country null to be displayed just in case I actually had didn't have anything. Okay. Okay. And now again, something you cannot do with SQL: denormalization. This was normalized, right? These were normalized data sets. First normal form, there is nothing nested. It's 2 tables. We can join them. What people love to do when they want to go big data analytics and so on is to start nesting things. For example, what if you list the stores and you nest all the products for every store? Now you have nested structured in there. This is in fact a specific kind of join in order to do that. You basically join the stores with the products, but you use a let here instead of a for. And by using a let, you will bind for every store $P to the sequence of products in that store. So $P is a sequence. This is how you get the sequences there. How did I turn them into arrays? Well, this is because I use these square brackets right there. That's how I turn them into arrays. Okay, for whom does that query make sense? So you see, this can be used as a Swiss Army knife to remodel your data. If you didn't like this way of storing the data, or you want to pre-join, then you can write a RumbleDB query and export it back to a data set where now it's a single collection, but it's all nested in there, right? And then you can read that in some other tool that you want to use. Okay, let me check the time. Yes, there is a question, yeah.
Previous query, if we wanted to store the distinct products, we would just add the next one. Here, we would make distinct values on the let.
Yes, exactly. You have exactly the right thinking. Indeed, if you had put around this $p.type a distinct value call, you would have then on top of that eliminated the duplicates. What that would mean is that teapot would only appear once and TV would only appear once. The reason why this is the right thinking is that you are thinking like the Lego game. That's exactly the right way of thinking. You can put any expression anywhere, literally, and it's going to make sense. Okay. I'm checking the time. It's already only a few minutes, but maybe I can show you that there are types as well. If you're not obliged to, you don't have to specify the types, but if you want, you can. I think it's also something that was added to Python in a recent version. It's super useful for making things faster. And also it informs you if there's any error with the types that you would expect. So now you could take the query over earlier, but I just added the types. So path is a single string. Events is a sequence of objects. Star is like the regular expressions, 0 or more. Actors is a sequence of objects. Logins is a sequence of strings. Distinct logins, a sequence of strings. Count is a single integer. There is no star in there. And so you see the type system, how it works. This is like this. You have single items, just the name of the type. Question mark is how many? Just like the regular expressions, 0 or 1. So that can be Boolean, that can be the empty sequence or a single Boolean. Array plus, again, like regular expressions, it means a sequence of 1 or more arrays, cannot be empty. And object star means a sequence of any number of objects. Can be empty, can be 1, can be 10, can be a billion, right? So you can do things like that. For example, this is a sequence of at least one array. If it wasn't the case, you would get an error, basically, at runtime. But in that case, there's no error because it is indeed a sequence of 2 arrays. So that's totally fine. And $x has 2 arrays. And that returns then the content of the array. So what does this query return? So it's a sequence of items in any case, but what are the items in the result? 1, 2, exactly. It's a sequence of 2 integers. You have an instance of, just like Java and C++, that would return false, of course, because that's not a sequence of integers, right? There is a string in there, so that would be false. You can test for castability. I don't think it exists in C++ or Java. You can test whether you would succeed if you tried to cast that as a double. So that would say true, because if you attempt to cast that as a double, that would work. And you can also have functions and pass the type of the parameters to the function, but again, it's optional. You don't have to. You can also omit the types. So here we declare a function where the threshold is an integer, objects is a sequence of objects, and it returns a Boolean. And that returns just a comparison. Is my count of objects greater than my threshold? So that's an example of function, right? For whom does that make sense? And again, the types are optional. You can drop them. If you don't like the types, then drop them. That will work as well. But if you don't specify any types, it's going to assume a sequence of items. That's the most generic type. It's item star. That just means a sequence of items. All right. That was very busy today, right? So let me check that you've been following. If it lets me, of course, because probably it's going to, yeah, exactly. No, that's it. All right. So what's the one thing that I want you to understand? It's really, again, this is the Lego game. This is the Lego game. There are less than 40 pieces in total. You can assemble them as you want. One of the pieces is super important. That's the flower expression. It's a generalization of select from where you can have them in any order. And you can visualize the flower expressions with this table-like representation of the streams of bindings, the streams of tuples. Okay. And again, for those of you who might be below 80%, you'll have a lot of practical exercises. You can go to the sandbox, to the online sandbox. You can download RumbleDB, play on your laptop. You can really play around and experiment with it. That's the best way to learn. I can only go so far with a theoretical lecture. All I can do is show you slides and what that does, but the way to learn is to do it. So do it. That's the next step. All right. So thank you very much, everybody. Enjoy the exercise session, and I'll see you tomorrow at 9 a.m. where we'll probably finish on JSONic. Thank you.